Okay. All right, so this is a guided walkthrough for day 8 of the TryHackMe Advent of Cyber event. It is task number 14, and it is in the Shellcodes category. The title of the exercise is called Shellcodes of the World Unite. Okay, let's get started. So Glitch the hacker, clever yet distrusted, wrote a script with skills finely adjusted, shellcode magic to his home it would send, where secrets of Wereville he'd carefully penned. Glitch, a skilled but mistrusted hacker, was prepping for a tech conference. He was eager to share his shellcode script that remotely accessed his home system. As he worked, he noticed Mayor Malware's henchmen lurking nearby. They're wasting their time. I don't have anything they'd want, Glitch chuckled. He didn't realize that hidden in his home system was something they desperately sought. A research paper he wrote on Wereville's defenses, a treasure Mayor Malware was eager to obtain. Learning objectives. Grasp the fundamentals of writing shellcode. Generate shellcode for reverse shells. And execute shellcode with PowerShell. Connecting to the machine. Before moving forward, review the questions in the connection card below. So, do we need to start the attack box machine today? Yes. Do we need to start a VM today? Yes. Is there split screen available? Yes. And am I given credentials to connect directly to the VM via RDP, VNC, or SSH? Yes. Okay, so we need to click on 2 buttons before we're able to do today's exercise. We need to click on this green start machine button over here. So let's click on that. And then let's go up to the top of the web page and click on the Start Attack Box button over here. So go ahead and click on Start Attack Box. So we're going to need both of these virtual machines to complete today's exercise. All right, so those 2 machines are loading up. They should take about 2 minutes to load up. And let's just go down to the description here. And let's talk about shellcode. So essential terminologies. A reverse shell to his system so tight, he planned to showcase at the tech conference night. Eager to share how his shellcode could impress, he aimed to enlighten, to teach, and progress. Before we start, review some important concepts to help you better understand the upcoming content. Shellcode is an advanced topic, but knowing these foundational ideas will make the rest of the material more accessible and engaging. What is shellcode? A piece of code usually used by malicious actors doing exploits like buffer overflow attacks to inject commands into a vulnerable system, often leading to executing arbitrary commands or giving attackers control over a compromised machine. Shellcode is typically written in assembly language and delivered through various techniques, depending on the exploited vulnerability. What is PowerShell? A powerful scripting language and command line shell built into Windows for task automation and configuration management. It allows users to interact with system components and is widely used by administrators for legitimate purposes. However, attackers often use PowerShell as a post-exploitation tool because of its deep access to system resources and ability to run scripts directly in memory, avoiding disk-based detection mechanisms. Windows Defender, a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks, by scanning code at runtime. Common bypass methods for evading Defender include obfuscating scripts to disguise malicious content, making it harder for the software to recognize known patterns. Another technique is reflective injection, where malicious code is loaded directly into memory, avoiding detection by signature-based defenses. We will cover the latter one in this task. The Windows API. The Windows Application Programming Interface, otherwise known as API, allows programs to interact with the underlying operating system, giving them access to essential system-level functions such as memory management, file operations, and networking. It serves as a bridge between the application and the operating system, enabling efficient resource handling. The Windows API is crucial because many exploitation techniques and malware rely on it to manipulate processes, allocate memory, and execute shellcodes. Common Windows API functions require frequently used by malicious actors include virtual alloc, create thread, and wait for single object, which we will also use in this task for exploitation. Accessing Windows API through PowerShell reflection. Windows API via PowerShell reflection is an advanced technique that enables dynamic interaction with the Windows API from PowerShell. Instead of relying on precompiled binaries, PowerShell reflection allows attackers to call Windows API functions directly at runtime. This will enable them to manipulate low-level system processes, making it a primary tool for bypassing security mechanisms, interacting with the operating system, and executing code stealthily. Reverse shell, a type of connection in which the target, the machine that you're trying to hack, initiates a connection back to your attacking machine. In this case, your machine will be the attack box. Okay, so in the case of a reverse shell, you've got an attacker system and a victim system, and the attacker system is going to set up a listener on a specific port, for example 4444, and then once you have access to the victim system, from the victim system you will create a connection back to the attacker system from it. And it's called a reverse shell because it is not the attacker connecting to the victim, it's the victim connecting back to the attacker, which is the reverse. Generating shellcode. But Mayor Malware's minions, Sneaky and Sly, found his script and gave it a try. They tampered the code, changed port and IP, twisted his work with a sinister glee. Let's learn how to generate a shellcode to see what this looks like. To do so, we will use a tool called MSF Venom to generate a reverse shell. In the attack box, open the terminal and enter the command, this one over here, MSF Venom, and all this stuff over here. This is going to generate the shellcode. The output will be like the following. You are required to replace the attack box IP with the IP of the attack box. So to know the IP of the attack box, we can actually take a look. So this is the attack box over here. We're going to be using two different machines in this exercise. So over at the bottom here, there are two tabs. There's the THM attack box and there's the AOC shellcoding v5. So we can click between the two machines over here, and what we're actually going to be doing is we're going to be putting these machines in full screen in just a little bit, but before that, so you can use this tab over here to switch between the two machines inside the split screen over here. So we're just going to go back to the attack box with this tab over here. Okay, so inside the attack box here in the terminal, click into the terminal, hit enter to dismiss this screen over here. And we're going to start our terminal inside the attack box here. So the attack box has this, this white Yeti creature as the desktop background. You can click on this button over here to start up the terminal. And inside the terminal here, we're going to run the MSF Venom command. So we're just going to copy the command here all the way up until the end of the word PowerShell. Copy it, and then we're going to click on this button over here, which is going to open up a little control bar. We're going to click on this clipboard over here, and then we're going to paste that command into the clipboard. After we do that, we're going to close the clipboard by clicking on this button over here. And then in the terminal, we're going to paste in the command. So, but before we run the command, we need to change out the lhost value over here. And we need to replace it with the attack box IP. The attack box IP is conveniently located over here. So in the terminal window, it's going to show you the attack box IP. In my case, it's going to be this one. Okay, so after you've replaced the IP address over here for the lhost, hit enter, and you're going to see the command come out in just a moment or two. But let's skip over here. So the above command generates a piece of shellcode using MSF Venom. Here's what each part means. So this part over here, Windows, P, Windows, x64 shell reverse TCP. The P flag tells MSFNM what type of payload to create, and this over here is the type, which is a shell reverse TCP payload. Okay, this specifies that we want a reverse shell for a Windows machine. We've got lhost attack IP. This is the IP address of the attack box. It tells the reverse shell where to connect back to. And lport 1111. This is the port number on the machine that will listen for the reverse shell connection. When it connects back to you, it will use this port 1111 in this example. You can choose any available port, but it needs to match with what your listener is set to. And F PowerShell. So the last section here is F PowerShell. This specifies the format for the output. In this case, we want the payload to be in PowerShell format so it can be executed as a script on the Windows machine. So what is the actual shellcode? The actual shellcode in the output above is the hex-encoded byte array, which starts with this over here, these hex codes over here, and so on. The hexadecimal numbers represent the instruction set on the target machine. Computers understand binaries, ones and zeros, but hex numbers are just a more human-readable version. It's not all that much more human-readable, but it is more human-readable than zeros and ones. So instead of seeing long strings of zeros and ones, you see something like 0xFC instead. So we can execute this shellcode by loading it into memory and then creating a thread for its execution. In this case, we can use PowerShell to call a few Windows APIs via the C# code. Below is a simple PowerShell script that will execute our shellcode. So you have to be careful with this because your antivirus is going to pick up this and it's going to inform you that this is malicious code, and they'll probably delete it as soon as it sees it. So that's a lot of code. But don't stress, we'll break down what it does step by step. If you're new to cybersecurity, memorizing these functions is unnecessary. Most penetration testers use pre-made or automated tools to run shellcode, so you don't need to know every technical detail to complete the job. No need to worry. So basically what the script does is it sets up the environment where we can run our shellcode, and then we can insert the shellcode with this command over here. So we've got an explanation of the code. The script starts by defining a few C# classes. The classes use the DLL import attribute to load specific functions from the kernel 32 DLL, which is part of the Windows API. So we've got virtual lock. This function allows memory in the process's address space. It's commonly used in scenarios like this to prepare memory for storing and executing shellcode. Create thread. This function creates a new thread in the process. This thread will execute the shellcode that has been loaded into memory and wait for single object. This function pauses execution until a specific thread finishes its task. In this case, it ensures that the shellcode has completed execution. These classes are then added to the PowerShell using the add type command, allowing PowerShell to use these functions. Storing the shellcode in a byte array. Next, the script stores the shellcode in the buff variable, a byte array. In the example above, shellcode placeholder is just there to show you where you would insert the actual shellcode earlier generated through NSFNM. Usually, you'd replace it with the real shellcode, represented as a series of hexadecimal values. These hex values are the instructions that will be executed when the shellcode runs. Allocating memory for the shellcode. The virtual lock function then allocates a block of memory where the shellcode is being stored. The script uses the following arguments. 0 for the memory address, meaning that Windows will decide where to allocate the memory. Size variable for the size of the memory block, which is determined by the length of the shellcode. 0x3000 for the allocation type, which tells Windows to reserve and commit the memory. And 0x40 for memory protection. The memory is readable and executable, necessary for executing shellcode. After memory is allocated, the marshal.copy function copies the shellcode from the buff array into the allocated memory address adder, preparing it for execution. Executing the shellcode and waiting for completion. Once the shellcode is stored in the memory, the script calls the createThread function to execute the shellcode by creating a new thread. This thread is instructed to start execution from the memory address where the shellcode is located. which is the variable adder. The script then uses the wait for single object function, ensuring it waits for the shellcode execution to finish before continuing. This makes sure that the shellcode runs completely before the script ends its execution. All right, so time for some action, executing the shellcode. On the attack box, execute the command nc nlvp 1111 to start a listener on port 1111 and wait for an incoming connection. The command opens port 1111 and listens for connections, allowing the attack box to receive data once a connection is made. Okay, so this is what we're going to do. On the attack box, which is over here, we're going to open up a new terminal. So inside the new terminal, we're going to run this command, which is netcat and then -nlvp 1111, which is going to start up a netcat listener on port 1111. After we execute it, we see that it is listening on port 111, and which means that it's available to receive incoming reverse shell connections. So after we do that, on the attack box, begin by navigating to the desktop, right-click on the desktop and select Create Document, and then choose Empty File. Open this new file and paste the previously provided PowerShell script code into it, looking for the part labeled Shellcode Placeholder, and replace it with the shellcode we previously crafted with MSF Venom. What are we doing? Okay, so on the desktop, what we're going to do is we're going to click into the desktop and then we're going to right-click on it. After we right-click on it, we can select this over here, Create Document. We can select an empty file. And then we're going to close out, we're going to minimize our terminals over here. And the new file over here, we're going to name it. So the new file, we're just going to call it script.txt. And then we're going to open it. So we're just going to open it by double-clicking on it. And what we need to do now is we need to paste in the PowerShell script. So we're just going to navigate up in the TryHackMe page, and this is the PowerShell script over here. We're just going to highlight all this all the way up until this one, wait for, and ending with this bracket over here. So copy it, and then go over to the control panel here, click into the clipboard, delete what's there, paste into the clipboard, and then click on the control bar again. And then in our script.txt file, we're going to paste in the script. Okay. And we're going to navigate down to the bottom of the script where it says buff equals shellcode placeholder. All right. So buff equals shellcode placeholder. What we're going to do is we're going to click on the terminal, which has our shellcode over here. And then right after the buff equals here, we're going to highlight all of the bytes over here. Highlight all the bytes until the last one here. Copy it. All right, so after we copy the shellcode, we need to go back to the document. And in the document here, we're going to highlight the word shellcode placeholder. And then after we do that, we're going to paste in the shellcode that we copied from the terminal. So right-click, paste. Okay, and then all the shellcode should be pasted in. All right, so we've got, so this document is now complete. We're going to save out the document. So we're just going to go to File and click on Save. Okay. So over here, once you've added the shellcode, navigate back to the attached VM, open up PowerShell, and click on the PowerShell icon in the taskbar, and paste parts of the code from the document you recently created to the Windows PowerShell window. For example, the first part to copy and paste is the block below. Okay, so what we're going to do is we're going to copy the commands from the script and we're going to put it in the vulnerable Windows VM. But the first thing we need to do is we need to go over to this tab over here called AOC Shellcoding version 5. Click on it. So we're going to put this in its own, we're going to put this VM in its own browser tab. And we're going to do that by clicking on this button over here. So over here, there's a button called View in Full Screen at the bottom of the split screen. Go ahead and click on that. And that's going to put the Windows machine over here in its own browser tab. So after you've done that, we're going to open up PowerShell. So PowerShell, you can open it up by clicking on this button over here. So it's this blue icon at the bottom. Click on that. And that's going to open up PowerShell. So I'm going to take up this part of the screen with PowerShell. And just to make it easier for everybody to read, I'm going to change out the properties. And I'm going to make the font bigger. And make this 24. Okay. All right, so this is much bigger. And another thing I'm going to do is I'm going to start up the Firefox browser, because there's a problem with copying and pasting between this machine. So I'm just going to open up Firefox, and it's going to take a little bit to load up. And I'm going to use Firefox to communicate with the attacker machine, and then get the script commands that way. So we're just going to have our Firefox over here. I'm going to resize it. Okay. And what I'm going to do is I'm going to get the script from the attacker machine. So back at the attacker machine, which is going to be on TryHackMe THM attack box over here. So click on the THM attack box button over here. Okay. And then what we're going to do is we're going to start up another terminal. So I'm going to this terminal here. And in this terminal, I'm going to, first of all, I'm going to clear. The second thing is I'm going to move into the desktop directory where the script file is. So I'm going to move into cd /desktop. And if I take a look in this directory, we've got the script.txt file here. Anyways, okay, so now that we're in the desktop directory where the script is, we're going to set up a web server. So the web server is going to be used, we're going to use Python to set this up. So it's going to be Python 3 -m, and then it's going to be http.server. And we're going to set this up on port 443. Okay, so after we do that, we're going to access the script.txt file from the Windows machine. So we're going to go over to the tab where the Windows machine is, and we're inside the Firefox window here. We're going to reference the attack box IP. Oh, I need to get the attack box IP. So the attack box IP is 1010. So this attack box IP is going to be different for you than it is for me, but for me it's 10.10.108.86. 10.10.108.86. We're going to prepend that with HTTP. We're going to do :443 because that's the port we're on, and then /, and then script.txt. Hit enter. And this is the script.txt file that we created. I'm going to make this a little bigger so that we can read it. Okay. All right. So what are we doing now? We're going to be copying this script, and we're going to be running these commands on PowerShell. So what we need to do is we need to go up to the top of the script. We need to grab everything from the top of the script all the way up until before this byte array over here. So the reason why we can't paste in everything at once is because if we paste in everything at once, then Windows is going to detect the malicious code in here, and it's going to shut it down. It's going to delete everything. So, so we have to do this in chunks. So we're just going to copy this chunk, and then we're going to paste it into the PowerShell over here. So just Control V to paste, and then hit enter. So that's going to run all of this code over here. After that's finished, we're going to go down here and we're going to copy, we're going to copy all of this over here, which is the byte array with all of the shellcode. So just copy all that until the end of the shellcode, which is the X0D5. So copy all this, and then in the PowerShell window, click into it and paste, and then hit enter. So that's going to take a little bit to load into PowerShell, but in the meantime, you're going to copy the next line, and the next line is this one over here, which is intptr. Copy that, and then in PowerShell, go down. In PowerShell, paste that line, hit enter. Okay, that went through. And then we're going to paste the next 3 lines one by one. So copy this line, and then in PowerShell, paste it, hit enter. And the same for the next 2. Copy the next line, copy, paste it, hit enter. And the last line here. Copy the last line, and then in PowerShell, paste it, and then hit enter. So once you paste in and enter the last line, go over to your attack box, which is over here, and you should notice that the terminal window where you started up the netcat listener on port 1111, you now have a connection from the victim machine, which is the Windows machine. So we are now C users glitch. If you ask who am I, it will say that you're a glitch. So we've essentially gotten a reverse shell connection from using shellcode that we pasted into PowerShell. Okay, so that was the goal of the exercise. So we're gonna actually do this one more time. So to do this one more time, what we're gonna do is we're going to replace the shellcode. Instead of the netcat listener running on 1111, we're gonna have the netcat listener running on port 4444. So we need to modify the script a little bit. So first of all, what we need to do over here, so we've got our Windows connection. We don't need our Windows connection here. We're just going to exit. And then we can run our previous commands. Actually, we can't run our previous commands. Okay, so here what we're going to do is we're going to set our netcat listener up on port 4444. So it's the same command, except instead of 1111, it's 4444. Hit enter, and now we have a netcat listener running on port 4444. Okay, so we're just going to put this terminal window away for now. And the other terminal window, where is it? Let's grab the other terminal window. In this terminal window, this is the one with the Python server. We're going to exit out of it. So it's Control C to exit, and then we're going to use our previous commands, and we're going to go to the nsfvenom command. So the nsfvenom command, we're going to run it again, but instead of port 1111, we're going to replace it with 4444. So we just need to go to the number and replace 1111 with 4444. After that, hit enter. It'll take a couple of seconds to run, but we're going to get our new shellcode, which is going to create a connection on this machine on port 4444. Anyways, so inside of here, after the buff equals, grab the first hex number and then go all the way down, and all the way down until the last hex number, which is 0xd5. So highlight it all and then copy it. Then go over to your script.txt file over here and highlight all of the hex code here. So the hex code here, we're going to replace it. We need to highlight it all until the very first one. So the very first one is this one, 0xfc. So after we have all of the hex code highlighted, paste in to replace it. Okay. After you've done that, we're going to save out the file again. So File, Save, and then we're going to go over to our terminal. In our terminal, here where we made our hex code, we're going to start up our Python web server again. So it's going to be, we're going to go back in our commands. We're going to run this command again, python 3-m http server 443. So run that again, and now we're serving the script.txt file again, the updated one. All right, so we've got the HTTP server running. So over at the Windows machine, we're going to, inside of Firefox here, we're going to reload this page because we've updated the page. So we're just going to reload, and we see that the hex code over here, it changed a little bit. We're going to need to open up our PowerShell window again. So go ahead and click on the PowerShell icon again, and then let me resize this window. All right. So we need to, what we're going to do to finish the exercise is we're going to create another connection via reverse shell using the shellcode and the script. So one more time, we're going to highlight this part of the script and go all the way down to before the bytecode. So right here, highlight all that, copy, and then in PowerShell paste, and then hit enter. After that, go back to the script and copy all of the bytecode over here. Copy all the way down until 0xd5. Copy all of it. And then in PowerShell, paste it in. Hit enter. And just like the other time, we're going to copy the last 4 lines one by one and then paste them into PowerShell one by one and run them. Okay, we've got our second one. So we've got the second to last instruction and then the last instruction. Just copy that again. And then after you execute the last instruction, go back to the attack box. And in the attack box, you should see that the terminal window where you created your netcat listener, you should have a connection from the Windows machine. And what we need to do is we need to collect the flag, and then we're finished with this exercise. So let's just go down to the bottom and let's do this. So regaining access. Now Glitch must act no time to delay to fix the shellcode and keep foes at bay. He tweaks and he codes to set the wrongs right, protecting his secrets with all of his might. Let's dive into the story and troubleshoot the issue in this part of the task. Glitch has realized he's no longer receiving incoming connections from his home base. Mayor Malware's minion team seems to have tampered with his shellcode and updated both the IP and port, preventing Glitch from connecting. The correct IP for Glitch is attacker box IP, and the successful connection should be on port 4444. Can you help Glitch identify and update the shellcode with the correct IP and port to restore the connection and reclaim control? Okay, so this is what we've done. To finish the exercise, we need to go into the desktop directory. So if we do dir here, we'll see that there's a desktop directory. So we're going to cd into desktop, and we should see a flag file here. So we just need to read this flag file to complete the exercise. Type space flag.txt. Okay, so this is the flag right here. Copy it. Whoops. Copy it, and then go over to the clipboard. In the clipboard, copy it again, and then paste in the flag over here. Paste in the flag, click on submit. All right, that is the correct answer. Okay, so the last question is, are you interested in learning more about evasion? Take a look at the AV Evasion Shellcode room. So all we need to do is click on the complete button, and then we're done. Okay, click on that, and then the whole task turns red, so we're finished with this day. All right, thank you very much. And that was a guided walkthrough for the Advent of Cyber 2024 event, day 8, and we will see you next time.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button, and if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.